Okay, 10.4 notes, polar coordinate graphs, page 1. So polar graphs have a direction. It's going to be important that you plot these points in order because they can wrap around on themselves. It gets a little confusing. It's nice to be able to test for the symmetries, understand the symmetries so that you know where you can stop graphing and just copy something into another quadrant and cut down on some of the work for yourself. Okay. So we have 3 possible symmetries when we talk about polar graphs. It can be symmetric with respect to the line theta equals pi over 2. So that's our vertical axis. Easy enough. It can be symmetric with respect to the polar axis. That's our horizontal axis. That'll be the second thing we look for. It can also be symmetric with respect to the pole, which means we're looking at a 180-degree rotation. Okay. And that does give us another type of symmetry we can look at. So here, example 2, we're going to test the equation where r equals 2 sine theta for symmetry using the rules we've been given above. Okay, so if we want to check for symmetry with respect to the line theta equals pi over 2. So with respect to theta equals pi over 2. And all I'm going to do is take a look at what it tells me right here to do. I'm going to replace r theta with negative r negative theta and see if I end up with an equivalent equation. So I have got, let's see, r equals 2 sine theta. I'm replacing both r with negative r and theta with negative theta. Okay. I know that because sine is an odd function, if I plug in negative theta, I get negative sine, so I can rewrite that this way. I've got negative r equals negative 2 sine theta. Let's write this here. Odd identity. I can multiply both sides by negative 1. I get r equal 2 sine theta. So this equation passes this symmetry test. So this is going to be symmetric across that vertical axis, that line theta equals pi over 2. So symmetric with respect to or across. Okay. And so let's take a look at our next one. B. With respect to the polar axis, I'm going to take a look at what it tells me here. I'm going to replace r theta with r negative theta. So I'm starting with the same function, r equals 2 sine theta. And it says now I'm going to replace this with, I'm going to replace my theta with negative theta. I get r equals negative 2 sine theta, which does not equal 2 sine theta, right? That would be a reflection. So I'm trying to give myself some room here. Does not equal 2 sine theta. So it fails this symmetry test. Okay, now here is the one thing that I can tell you. Just because it fails a symmetry test does not mean it will not be symmetric. I know, useful, right? But we used the fact that these can pass the symmetry tests to definitely eliminate some of the work for us. So we're taking a look at the last one. With respect to the pole, r equals 2 sine theta, starting with the same function. We're taking a look at what it says here. We're going to replace with negative r theta. So now I have negative r equals 2 sine theta. I can multiply both sides by -1 and get r equals -2 sine theta, which, as we just mentioned a minute ago, does not equal 2 sine theta. So it also fails this test for symmetry.